star visibility. The American Astronomical Society cited a study saying that light pollution has led to a decrease in star visibility for, oh my gosh, light pollution has been increasing 10% each year since 2011. I chose this experiment because I love photographing the night sky and wanted to know how light pollution, known as sky glow, affects it. I specifically wanted to know if I drove far away from Seattle city lights at night, how would that affect the photo if I aimed at the city? Oh my gosh, can I just be sorry? I'm so sorry.
That's okay. Go ahead.
Okay.
It's okay, we're not scary. Honestly, I feel like you know both of us. We're good.
Yeah.
We're good.
That almost makes it worse.
You got this, right? You do.
Did you know that our night skies disappeared? Light pollution has led to a decrease in star visibility. The American Astronomical Society cited a study saying that light pollution has been increasing 10% each year since 2011. I chose this experiment because I love photographing the night sky and wanted to know how light pollution affects it. I specifically wanted to know if I drove far away from Seattle city lights at night, how would aiming the camera towards Seattle and away from Seattle affect what is called absolute gray pixel height, which I will refer to as AGPV. AGPV is measurable in numbers and indicates the amount of darkness in a photo. Light pollution raises the AGPV. The higher the light pollution, the higher the AGPV. The lower the AGPV, the less stars you can see. So the aim is low AGPV. My research question centered around finding where in the night sky the lowest AGPV could be found. I would like to point out this research question could not be possible without cameras. Cameras have long been used as a scientific instrument. Astronomers have used them to discover stars, conduct sky surveys, and for star classification. Using a camera for studying stars protects astronomers from the mistakes of human error and helps detect data that cannot be detected by the human eye. The beginning of astrophotography was in 1839, where Louis Jacques Daguerre attempted to photograph the moon, though it was too blurry to define the subject. Since then, light pollution has severely grown, gaining the title of sky glow, and has become a big enemy in the field of astrophotography. For my experiment, I used a Nikon D850 for the camera body, an advanced lens, a tripod, a protractor, and a compass. I drove to Forest Road 70 near Greenwater, near the first bridge. I was here. Seattle was 44 miles to the northwest, and Yakima was 60 miles to the southeast. The black line shows the angle at which I pointed the camera. Use a compass to ensure accuracy. I took 5 photos per experiment. Each photo increased 30 degrees. So, I took 30 degrees towards Seattle, 60 degrees towards Seattle, 90 degrees straight up, 60 degrees towards Yakima, and 30 degrees towards Yakima. At the start of my experiment, I hypothesized when I pointed the camera furthest away from Seattle, that would result in the darkest nighttime photos with the lowest AGPV. My hypothesis was wrong. I was shocked to find that 90 degrees, or zenith, had the best results and the lowest AGPV. Seattle's sky glow dome is so large it has merged with Tacoma's, forming a wall of sky glow to the west. It made sense that pointing the camera as far east as possible would have resulted in the best photos, because Yakima's sky glow would have been lesser, and because it's a smaller city. But even that raised the AGPV. That just goes to show how powerful sky glow can be. The following chart displays my results for all the photos I took with the AGPV. These numbers were taken using image J. Image J, unlike the human eye, is totally objective, with no with no variable factors because it is generated by software. You can see on my chart, both times Zenith had the lowest AGPVs. Both tests followed the exact same pattern. The night sky in the first experiment was ran under cloudy conditions, while the night in the second was ran under clearer skies. Both times, the Zenith had the lowest AGPV. What? I already said that, whatever. This meant the photos were the darkest, had the least light pollution, and gave most data about the sky. Each day, we lose fractions of our night sky to the development of our cities. Blue light especially is adding to this problem, more than any other kind of light. So, this begs the question, are these conditions reversible? We may not be able to get rid of all of the light pollution in the night sky forever, but we can help this matter by closing our blinds nightly and the city installing lights that will that have shields around them to point directly down rather than having some light come up. I would like to thank my parents for helping me with this project, my siblings for helping me clearly understand challenging concepts I came across, and you judges for taking time out of your day to help.
I would love to. Okay, first question. What kind of moon was it each of those nights? Was it roughly the same moon, or was it a full moon versus a half moon, or what was the moon?
It was,
do you remember?
I'm pretty sure it was half, although it was just under the trees.
Okay.
So I don't think that came across in any of the photos.
Okay. And then you said that the 90-degree one was the darkest, which is fascinating to me, because to me they look like some of the lighter photos.
Yeah.
Can you explain how that works?
So originally all of these photos were from Walmart. That's how we printed these out. But these two came across like an error or something was on them. So we reprinted them, but these were from Walgreens. But so it might look different to the eyes, but the Zenith on both photos, both nights, had the best results.
Okay.
Ryder, first I just wanted to say good job. I know that's hard to stand in front of people and present, and you had a lot of information in there, so I just wanted to say you did a really nice job. I liked your pointer, that you were making sure that you told us that where we can look as you were specifically talking about the pieces. I wanted to know, can you explain this chart for me?
Yes, this chart is the histograms this is what NHJ pulls up. So the numbers, you have all the numbers down here, they're a bit small, but they tell you all the information. So where we got these numbers from was the mean of each photo. So after all the calculations, that's the numbers that pulled up, and these charts up here just display like the darkness, so to speak, of the night sky. So the goal is the sharpest point to the sky, because you have, it's a scale basically, from 0 to 255. And on 0 it is the darkest you could possibly get, 255 the lightest you could possibly get. So all of these numbers, the higher they go, the worse the photo. So this is about mid, so to speak. It's right around there, and it just shows that that's like where the photo, which direction it goes in with the numbers.
And are you measuring this off of the photo or off of the night?
Well,
Like in the night sky, like are you pointing up? It's an app, right?
yes.
Okay, so how is it being measured?
Well, it takes the entire photo of the night sky, and each pixel, it measures the gray value, so to speak, of all of the pixels in the entire photo, and it takes all of those and averages that out. So that is the entire photo, so to speak. That's the rough estimate of the light pollution in it. It basically measures how light the photo is.
So you, just so I understand, so you have the photo like downloaded, and then you're putting it into this app and that is calculating the actual photo.
Yes,
Correct.
it's calculating how much sky goes in it.
Okay.
And it's measured by numbers or pixel value.
Can you explain, I loved her question about the moon, because in your experiment, your first experiment, there's a lot more light in those pictures than in your second experiment. And it was different times of the day, of the night?
It was roughly about just around that 8 hour for all of the photos, though on different nights. The first set of photos are more polluted because it was ran under cloudier conditions. So the light reflected off the clouds down and back into the lens of the camera. That's why all of these are so much brighter than the ones down there, because these are ran under clearer conditions. So all you really see is the light pollution from Seattle over here and light pollution from Yakima over here.
Do you think that the average would have changed if you would have done it a third time? Like if you would have tried to December, because it looks like your dates are fairly, like roughly the same time of month. I guess they're like a week off, but if you were to say, let's do one like towards the end of December, where, you know, like obviously it's a lot darker during that time, like how dark was 8 o'clock in November versus January? Like, do you know the sunset time or anything like that, or if December would have changed all of that outcome?
I do not know the answer to that question, but if there is snow, so to speak, it will change the outcome, though it would follow this pattern again, because it is all roughly the same amount of numbers, they're just all enhanced from the glare off the snow.
Could that have been what created more night glow pointed towards Yakima, because you're going up and over the mountains where there is snow? Is that something that could have had an impact on your results?
That very well could have been, because there was a little bit of snow when we took these second group of photos. And where we were, there was a bit of a hill going towards Yakima, but it leveled out. There was just like trees in the way of Seattle. So it'd probably look about the same as this, but Yakima would have been less if the ground was completely flat all the way to Yakima and Seattle.
It's just interesting, you talk about the snow and how that's gonna the night glow is gonna reflect off of that. And have you been up over the pass in that way from Greenwater up to Yakima? They close it down because there's so much snow that way.
Yeah.
And so it is curious to know if that actually had an impact on your results.
Yeah, that would be really cool to find out.
What was your, I'm sorry, what?
I was just gonna ask what his favorite part was, which I feel like is what you were gonna ask.
My favorite part, designing my board was really fun, trying to figure out how I wanted to do it, and probably taking the photos. I very much hated trying to write all this stuff down.
That's an honest answer. Who helped you take the photos? Because obviously you don't drive, so was it?
My mom and dad were in the car. My mom just wanted to like look over the outcome and how we took photos and stuff, but my dad helped me set up the protractor and he helped me set up the tripod and the camera, and then I took all the angles and hit the photos. We used a remote control feature on the camera, so we projected like little connector to where you just click a button on a remote and it takes a photo, so there was no human, like, yeah.
So you weren't accidentally bumping it or
Yes,
making
that's
it
what I was
move, like
trying to-
leaned on
yes.
it and,
Yeah.
yeah, that's good. Okay, I do have a question, cause I'm not a photography person. What is a histogram?
Oh, a histogram is like the. How do I explain this?
Give it your best shot, cause I don't know if I'm gonna understand it, even if you explain it well.
Okay. So a histogram is, take the photo and you have like a bar that you can go across. And it tells you all of the like data from that specific part of the photo. So it'll have different numbers here, so to speak, than here. And you can just move that over and forward and back, and it'll tell you like, this is how much light is in it, this is how much warmth is in the photo, this is how cold the photo is, so to speak. It just tells you all the like data
Okay,
of the photo.
so it's like all the info.
Yes.
Okay.
Yeah.
Is there anything that you would do different? What are the things that you would do different? I can't remember if you said so in your paper.
Anything I do different, I would probably. I don't know if I do anything different, so to speak. Maybe I take the photos at like 6 months, then 6 months later, to just see the entire like full year-round spectrum to see if all the numbers be the same. And maybe like each month I take another photo or something, just to see if this holds out throughout the entire year. But I didn't have that much time. Yeah.
Do you think using a different lens would have given you different results?
Yes. We took these photos with the widest lens we own, a Nikon 14 to 24 2.8 or f2.8. It is a big lens, so we probably would have gotten smaller numbers if we used a smaller camera, so to speak, because there isn't as much light that it can capture. So, yes, I would say that you would have gotten a little bit of a different answer depending on the lens.
I think I'm good. Thanks, Ryder.
Thank you.
Thank you, Ryder. Good job.